Good afternoon. My name is Stacey Snakenborg and I work as an ecological technician in the Baviaanskloof World Heritage Site for Eastern Cape Parks and Tourism Agency. I'm going to be giving a quick presentation on my master's thesis that looked at diet and demographics of leopards in the Baviaanskloof. So the reason for my study was that leopards globally have been declining, and this has led to them being classified as vulnerable by the IUCN and the South African Red Mammal List. Leopards are also a very highly adaptable species, which allows them to survive in human-dominated landscapes, and this leads to an increase in human-wildlife conflict. So by looking at density and diet, the hope is that we can get a better understanding of the population, as well as whether it's a viable population, and also just understand if there's any needs to change management priorities. So our research questions looked at what is the density of leopards inside the Baviaanskloof, will the leopard prey selection differ between protected and agriculture areas, and has there been any change in leopard diet since the study done in 2004? My study area encompasses the 1,234 kilometers squared Baviaanskloof catchment, which includes the protected area as well as the privately owned farmlands in the heartland area. Those are outlined in blue. And I divided my study area into four, three within the agricultural area and one within the protected area, and the land use differed by moving from active farmland and community into rest of farmland and then finally into the protected area. For my camera trap survey, I placed 131 camera traps across the 4 study areas over 4 sessions. Each session lasted approximately 180 days, with cameras being checked every 4 to 6 weeks. When we did the camera checks, we were downloading images, checking that they were still functioning, removing any vegetation, and also changing batteries if we needed. So yeah, that meant we spent 18 months in the heartland area and 6 months in the protected area, and this resulted in 21,040 trap days. For density, we identified individuals based on their coat patterns, which is unique for leopards, and we identified them based on left and right flank. And in order to avoid misidentifications and keep the independence of capture histories, we kept these separate when we did our analysis. Analysis was done using spatially explicit capture-recapture models in R, and to account for the assumption of closed populations, each of my surveys were divided into 3 60-day sample periods. Once all the data had been analyzed, we then added everything together to determine the density estimates for each of the study areas as well as overall. So what this resulted in, active farmlands, we see that there was a lower number of leopards captured with only 13 identified, and 1.4 leopards per 100 square kilometers was determined for density. This did have quite wide confidence intervals due to the low probability of captures. As we start moving into our rest of farmlands, we see that the leopard captures did increase, as well as leopards identified, and as did our density estimates from 3.6 to 4.02. And then finally, as we head into the protected area, we see that there was quite a big jump in our leopard captures to 195, with 34 individuals identified, and also a big increase in our density estimate of 7.7, with narrower confidence intervals due to the increase in capture probability. This gave us an overall density estimate at 4.22 leopards per 100 square kilometers for my study area. For diet, we collected scats opportunistically. In total, we collected 63, 47 from the heartland, where obviously we spent more time, and only 16 from the reserve. These were collected during camera trap setup, checks, and takedown. Hair cuticle analysis and cross sections was then used to identify prey species based off a reference library. After we had now identified all our prey species, we then grouped our prey according to large, medium, and small size prey, as well as domestic and bird species. Frequency of occurrence for each of the prey species was then determined to see how often a certain prey species was being consumed. And from frequency of occurrence, we then worked out the relative biomass indices to see how much the biomass of that species contributed to the leopard's diet. To determine whether there had been if there was any significance differences between the protected area and the agricultural area in terms of leopard diet, the chi-square test of independence was used. We also did the Jacobs index to see whether the leopard showed any preference or avoidance of any of the prey species. What we found was that medium-sized wild prey dominated the leopard's diet in both frequency of occurrence and in the relative biomass indices. Frequency of occurrence of small mammals was high, but their biomass contributed very little, whereas the frequency of occurrence of the large prey was low, but it contributed quite high to our biomass intake. So the main medium-sized prey species that the leopards were found to be chowing was our bushbuck. We found them in 21% of the scats, and they contributed to 22 to the biomass, followed by mountain reedbuck, which were found in 12% of the scats, contributing 13% to the relative biomass. And then finally, our common or grey duiker was found in 16% of the scats and contributed 12% to the relative biomass. We then looked at the large prey species, and the dominant ones was our kudu, which we found in 4% of the scats, but as you can see, disproportionately, they contributed 19% to the relative biomass intake. And then followed by Inyala, which we found in 3% of the scats, and contributed 6% to our biomass. Finally, small prey species, the main ones were the rock hyrax and the flay rat. They contributed, they were found in 13% and 6% of the scats respectively, but as you can see, that contributed very little in terms of the biomass. And then our domestic species were only found in 2% of the scats, and they only contributed 4% to the biomass. Then when we have a look at the reserve in blue and the agricultural area in red, we can see the medium wild prey was the dominant prey species in both areas, followed by small prey and then large prey, with domestic prey only being found in the agricultural area. And when we checked to see whether there was any significant difference between what the leopards were eating inside and outside, no significant difference was found. We then move on to changes over time, whether the diet done in 2004 versus the study done now in 22, whether there's been any change in the leopard's diet. The 2004 study is grey, the 22 study is yellow, and basically what we can see again is that medium prey dominated, followed by small, large, and then domestic. And when we went to see whether there's been any significant changes in the leopard's diet, there was no significant difference found. Now when we look at prey preferences, so obviously this is based on a scale of if it's a 1, it's preferred, if it's 0, it's neutral, and if it's a -1, it shows avoidance. So our preferred prey was found to be klipspringer, grysbok, kudu, and African wildcat, while they showed neutral preference towards bushbuck, domestic species, duiker, and rock hyrax. And interestingly, they showed avoidance for mountain reedbuck, which is interesting considering it occurred in 12% of our scat samples. So for the conclusion for density, as we move from active farmlands into the rested areas and the protected areas, we can see that our number of leopard captures and identified leopards does increase, which led to an overall density estimate of 4.2. And this is comparable to other studies done on semi-protected areas with mixed-use landscapes. Then when we go on to diet, we found that medium-sized wild prey dominated the diet both inside and outside the reserve. And again, this is comparable with other studies where leopards preferentially show to target prey species within the 10 to 40 kg range. So basically, what does this now tell us about our population and where do we go from here? So basically, it says that our population Baviaans is showing that our population is surviving based on prey availability, habitat heterogeneity, and the ability for leopards to find a protected refuge here. Their numbers are, however, constrained by anthropogenic constraints. And this means that the management of landscape-based management is very important in the Baviaanskloof, and basically we have a healthy, viable population. Thank you so much. Any questions? Well, sorry, you can't ask me any questions, but otherwise I hope you really enjoy the rest of the thicket 4 and stay warm. Bye.